So this is part 3 of the 2023 questions provided by ACR. I'll put part 1 and part 2 in the description below. Otherwise, let's get going. So question 10, it says a government primary school employed 40 teachers in 1980. So let's just highlight some key things. They employed 40 teachers in 1980. And this table above says the average number of students per teacher is equivalent to the numbers that we're showing up there. So I should have really started with reading the table first, but to make it clear what the table is telling us, it is saying that in 1980, if you were in the government primary sector, for every teacher, there would have been an average of 20.2 students, okay? If you were in the Catholic primary sector in 2021, for every teacher, there would have been an average of 15.4 students. Let's just write this as a rule. So however many teachers, so teachers times number in table gives you how many students. And we could reverse this if necessary, but for now, this will work in helping us get the information we need. So let's make sure that we're using the correct number. It's a government primary school in 1980. So it is this first one here, 20.2. So however many teachers there were, if you times it by 20.2, that should tell you how many students there were. So this school had 40 teachers. So we need to do 40 times 20.2 and see what we get there. So we'll go over to the calculator. So 40 multiplied by 20.2 is 808. So there you go. That's our answer, 808. No rounding needed because that's a nice whole number. So 808 is our answer. Question 11. A Catholic secondary school had a total enrollment of 1,098 students in 2021. So here we go. I had a feeling this may come up. This time, we are given the number of students, and we have to go backwards and figure out the number of teachers. So this rule up here, teachers times the number in the table, tells us how many students. We can do the inverse of that, the reverse. If we know the number of students, so students divided by number in table will tell you how many teachers. So when it comes to algebra in LANTITE, there's not too much of, well, they're not using variables and stuff like that, but you do need to know how to reverse a order of events to help you find missing numbers. So in this question, we're told there's 1,098 students. And then let's make sure we're using the correct number. It's a Catholic secondary school in 2021. So here we go, 12.2. However many teachers there was 12.2 students per teacher on average. But for this question, we've got 1,098 students, and we're trying to find how many teachers. So we're going to divide by 12.2, and that will give us the answer. So we'll go on the calculator. I'm just going to scroll up a little bit. So moving over to the calculator, 1,098 students divided by 12.2 students per teacher on average gives us that there's 90 teachers. Again, nice whole number. So we're done. Our answer is 90. Moving on to question 12. So question 12 is regarding a excursion to a beach, and we need to focus on where the high tides and low tides are in terms of the time of day. So we've got a table here which shows us when the high tides and the low tides are for each day. If you're not familiar with your 24-hour clock, that is something I would recommend revising, because we need to know, for example, that 16:30 would be equivalent to 4:30 p.m. But let's have a look at the conditions for our excursion. So the earliest time the class can arrive is at 9:30 a.m. The class must leave the beach no later than 2 p.m. Okay. and we need to be at the beach at least 2 hours before and 2 hours after a low tide. And we've got some multiple choice options down here. So personally, I would just be going through each of these days and making sure whether they satisfy the 3 criteria that we have. Don't bother with Monday though. Bit of advice in terms of saving time. It's not one of your multiple choice options. So there's some exam technique. So let's have a look at Tuesday. The low tide is at 10:29. We can't arrive until 9:30. So if we do 10:29, take away 2 hours, that's 8:29. So straight away, Tuesday is out. Moving on to Wednesday, the low tide is at 11 a.m. 11 a.m. take away 2 hours is 9 a.m. So again, we can't arrive until 9:30. So that is out. So on Thursday, the low tide is at 11:41 a.m. So if we take away 2 hours from that, that's 9:41 a.m. And this one's looking promising because we get to the beach at 9:30 at the earliest. So we can be there 2 hours before. If we add 2 hours to 11:41 a.m., that is going to give us, let's do it together, 11:41 a.m. plus 1 hour is 12:41 p.m. plus another hour is 1:41 p.m. And that's looking good as well because we can leave no later than 2 p.m. So Thursday is looking promising. But make sure you check Friday as well because we're all human and make mistakes. So we want to make sure that Friday does not work. So Friday's low tide is at 12:13 p.m. If we take away 2 hours from that, that is 10:13 a.m., which is fine. But if we plus 2 hours to this, that gives us 2:13 p.m. And we can't be there at 2:13 p.m. So Friday is not an option as well, confirming to us that Thursday is correct. All right, moving on to question 13. So in question 13, we have got a table showing us the weekly rent for some houses. House 1 has 2 bedrooms and has a weekly rent of $440, costs you $440 to rent that each week. House 2 has 3 bedrooms and it's going to cost you $480 to rent that, so on and so forth. But question 13 wants us to get the median of the 5 houses. So where this would catch out some of the students that I tutor and other people, in my opinion, is this number of bedrooms actually irrelevant. Okay, so that's why I'm putting across there. That is not going to help you find your median. If you're not sure median is the middle number, but you need to make sure that you order it as well. But we get a piece of paper where we can do some work-ins. So let's write down the 5 numbers first. We've got 440, 480, 680, 380, and 420. So this is kind of just like a rough version. We've not put this in order yet. So don't try and find your middle number until you've done that. So we're going to order them now from lowest to highest. So the lowest amount of rent, or cheapest, in other words, is 380. I'm going to tick them off to make sure I've done them all. After that is 420. You could tick it off here if it's easier for you on your paper. 440 is next, followed by 480, followed by 680. And easy way of checking again as well is there should be 5 numbers, which there are. We have 5 numbers. So the median is the one in the middle. So we could probably see quite clearly here that the middle is 440. But if not, this technique works as well. Get rid of one from the start, get rid of one from the end, get rid of another one from the start and another one from the end. And there you go. That shows us that our median, our middle value, is 440. So the option we want to choose is 440, which is A. Question 14. So question 14 and 15 are based on the same graph that we have here, who shows the number of people in various age categories who attended at least one cultural event in Australia. When we look at the graph, you can see that we've got our data grouped together. So 15 to 24, there's roughly 3 million people who in that age range went to at least one cultural event. So just giving you an interpretation of what this first column means to try and help you do the rest. It says in question 14, how many more people in the 15 to 24 year category attended at least one cultural event than people in the 75 and over category? So let's just highlight these key things. We're looking at the 15 to 24 category, and we're looking at the 75 and over category. Now, this is where you could use some estimation. It doesn't have to be perfect because we've got multiple choice options down below. So 15 to 24 is roughly 3 million. So I'm going to write here 15 to 24 is roughly 3 million. And we also need to look at the 75 and over category, which if we go here is just below 1.5 million. But I can still use 1.5 million as an estimate. But when I look at the multiple choice options, it might catch us out a little bit there. So I know this is not necessarily a perfect answer, but I am going to go for 1,400,000 because I know it's not 1.5 million exactly. Otherwise, it would have been on the line perfectly. So we want to find how many more people. That is suggesting a difference. So we need to take away these two values, okay? So going over to the calculator, we've got 3 million, 6 zeros, just be careful there. Take away 1,400,000. And that gives us 1,600,000, which is not one of my options, but we can tell straight away that it has to be A or B. So what we do now is we consider the fact that we said, well, if it was perfectly on the line, this would have been 1.5 million, and my answer would have been A. But the fact that it wasn't perfectly on the line means that this must be correct, okay? 1,700,000. So we use an estimate in there, and we use the fact that because it wasn't perfectly on the line of 1.5 million for 75 plus, option A could not be the answer. Question 15 is another one of those where we have to choose true or false statements. The first statement says the number of people in the 15 to 24 age group who attended at least one cultural event was more than double the number of people in the 65 to 74 age group. So you might want to compare visually, because when I look at the 65 to 74, the height of this bar is here. And I think if I double that, it's definitely going to be taller than this one here. But you can estimate it as well if you want to. 65 to 74 looks like it's about 2,300,000. And if we did 2,300,000 times 2, we're getting like into the 4 millions here. So either visually or using some estimating, we can tell that that one is false, okay? And then second statement, over 12 million people aged between 15 and 54 attended at least one cultural event. So let's have a look here. We've got to do some addition, and we're going to use estimating again, that's fine, but it says over 12 million people aged between 15 and 54. So what we're going to do, I'm just going to use a red pen, is we're going to add this number, because they're between 15 and 54, this number here, this number, and this number, and see what we get. And if we're doing estimations, that's fine. So we have used 15 to 24 already and said that was 3 million. So first group, 15 to 24 is 3 million, plus the second group between 25 and 34,000, which looks like it's about 3,600,000. This is an estimate, so don't worry. 35 to 44, looks like that's about 3,100,000. And then 45 to 54, again, looks like it's about 3,100,000. And there we do get over 12 million. So I've done some estimating on the calculator, but another technique I could have used is that all of these bars look like they're at 3 million or above. So because they're all at 3 million or above, then that is true. Okay. So whatever technique you use is up to you, but you can estimate and be confident in your answer. Or we could have used a shortcut. Well, these are all above 3 million. So we must have more than 4 lots of 3 million, which is 12 million. In the next video, we're going to do the non-calculator questions. So I hope to see you there.